In this video, I want to give an application of f-strings and lambda functions, and the point of this video isn't that the application is important, it's just meant to review f-strings and lambda functions. I need to import NumPy again, and I need a random number generator again. And usually when I do this, I do a default RNG parentheses, but I want to have repeatable numbers here, so I'm going to do seed equals 1. Okay, I tried it with seed equals 0 and it didn't work, so I'll show you what I mean in a second. So if I do ARR equals RNG.normal, and I want to have this in the same cell as the RNG definition so that it's always using the first instance of the random number generator, because if I ran this portion alone several times, I would get different numbers the subsequent times. So I want it to always be the same, like always immediately after we've instantiated the random number generator. So I'm going to make an array of 100 normally distributed random numbers with mean 0 and standard deviation 1. And let's look at how ARR is. Okay, and so I don't really like this scientific notation or this exponential notation. I feel like it makes it harder to tell what the sizes of these numbers are. So let me show you what happens if I do seed equals 0 instead. And then I get decimal numbers, and I like that. So that's why I wanted to use this seed, was so I could be sure I was getting exponential notation. And then I want to show you how we can get rid of that exponential notation. And the way we're going to get rid of it, notice how it's the same 3.45 as before. So how we're going to get rid of it is using NumPy's setPrintOptions function. And it's a little hard to read. The portion we're going to use is this formatter. Could probably do the same thing using precision, but then it wouldn't be using f-strings and it wouldn't be using lambda functions, which would defeat the point of this video. So, and this formatter is nice in general. So the help for this, or the documentation for this, is a little hard to read. It says formatter is supposed to be a dictionary of callables. And so it's going to be a dictionary. Dictionaries should have keys. And only key we're going to need to use is float, because these numbers are floats. So that's going to be the key, like the thing that comes before the colon. And the thing that comes after the colon is going to be a callable, which just think of that as a function. So that's where we're going to use the lambda function. And that's going to be something that takes as input the float, and as output returns how should this be displayed as a string. So you can think of this as like a string that's getting displayed, and we're going to tell it more precisely how to display that string. Okay, so let's see. So we're going to do np.setPrintOptions, and then formatter equals, okay, and then lambda. Input is going to be a floating point number. Oh, and so I'm already doing this wrong. You see what I'm doing wrong? So the formatter, it's supposed to be a dictionary. Okay, and here I was writing formatter equals a function. So let's be sure to change that into a dictionary. And the key is supposed to be the type, or the types that we want to say how to format. And so in this case, I want to use float. And the first time I tried making this video, I made a mistake and I wrote float without the quotation marks. But you really needed to have the quotation marks. Okay, so there's the key. And then the value is going to be the function that we want to apply to these floats. And here is where we're going to use f-strings. So input is some floating point number that I'll think of as x. And maybe it'll be a little more readable if I put it in parentheses. So this part is going to be the function that says, how do we format a float? So input is going to be x. Output is going to be some f-string. And if this part doesn't seem familiar, try rewatching the f-strings video. And then, so curly brackets says, replace this x not x as a string, but with whatever value is for x. Okay, so x is going to be something like this, 3.45 times 10 to the negative 1 float. And then I need to specify how to format it. And I'm going to use dot for f. Okay, so the f is for float here, and the dot for says give me 4 decimal places of precision. Okay, that didn't give me an error. That's a good sign. And now let's try running this again. So do you see how the 3.45 times 10 to the negative first? You see how that got changed into 0.345? And so the only thing I don't like about this is it looks sort of strange in that the commas are not at all lined up. And if you come up here, you'll see the commas are all lined up, which is sort of nice. And so one way I'm going to get around that is, and I had to look this up, this isn't pretty much none of these specific string formatting things do you need to memorize. I definitely want you to memorize how f strings as a whole work. You don't need to memorize for now these kind of specific formatting options, or especially this next one I'm going to show you. So if I put a plus here before the dot, then what that does is it says if it's a positive number, then put a plus sign on it. Okay, and so let's run this again. And now they're nice and lined up, but I still don't find it that easy to look at. Like the pluses look a little strange. And so another option that we can do is you can just leave a space instead of that plus. Okay, and now let's try running this again. And now they're all nice and lined up. These commas are all nice and lined up. Okay, I know we could have a whole week worth of videos on Pythonic code and ways to make your code more elegant, but I think I've already gotten through the main things I wanted to cover, which were list comprehensions, f-strings, and lambda functions. So I think next we'll go on to a new topic, which is how to make plots in Python using matplotlib.